You've got Postgres running, Redis for your cache, Mongo handling some JSON documents, and RabbitMQ pushing jobs around. That's 4 separate systems you're monitoring, patching, and keeping online.
Yeah, and Postgres already has JSONB, listen/notify, skip locked built right in. So the real question is, when does it actually make sense to consolidate, and when are you just building yourself a bottleneck?
Exactly. We need a framework for making that call, because it's not always clear-cut.
All right, let's start with why you'd even think about doing this.
The operational overhead is the biggest driver. Every extra system means another way things can fail, another set of credentials you're rotating, another piece that can get out of sync during disaster recovery.
It's not just ops, though. Your application code gets simpler. One transaction can touch your relational data atomically, simplifying interactions with your cache and queue.
That's massive. You're not dealing with distributed transaction problems anymore. No more eventual consistency bugs between Redis and Postgres.
Let's get specific. If you're running under 10,000 requests per second and your data set is under a terabyte, Postgres can absolutely handle caching, queuing, and document storage right alongside your relational workload.
The transactional consistency thing is huge. If your queue messages need to be created in the exact same transaction as a database row, like you're charging a card and queuing a receipt email, Postgres wins by a mile.
Team size matters more than people want to admit. If you're 5 people, do you really want to become experts in 4 different databases? Probably not.
Here's another. If your cache data or queued jobs actually relate to your relational data, like you're caching aggregates or queuing work based on table rows, keeping everything in Postgres means you can join across all of it. All right, let's go through this feature by feature. First, using Postgres for cache-like workloads where transactional consistency matters more than raw speed.
For basic key value caching, you can use an unlogged table that skips whale writes, so your inserts and updates are way faster, though Redis will still be faster for pure caching workloads.
The catch is that unlogged tables get truncated on crash recovery. But for a cache, that's fine. Actually, Redis loses everything on restart unless you've configured persistence, so this is similar behavior.
And unlike Redis, you can run complex queries on your cache. You can join cached aggregates with live tables, or filter with where clauses. That's really powerful.
Here's what it looks like. An unlogged table with a primary key on your cache key, JSONB for the value, and an optional expiry timestamp.
You'll want a partial index on expires at for cleanup, and a periodic delete or maybe a trigger to purge expired rows. That's how you handle TTL.
Now, this won't match Redis on raw throughput for single key gets. Redis is in-memory and optimized for caching. But if you're doing low thousands of requests per second and you need transactional consistency, this works really well.
So when should you keep Redis? If you need more than 50,000 reads per second on hotkeys, Postgres is going to struggle. Redis's single-threaded in-memory architecture is just faster for that.
Latency is another big one. If your P99 latency budget is under a millisecond, Postgres won't hit it consistently. There's query planning overhead, even on primary key lookups.
And if you're using Redis's advanced data structures, sorted sets, bitmaps, hyperloglog, Postgres doesn't have native equivalents. You'd be reinventing them in SQL, which is painful.
Also, sophisticated eviction policies. Redis has LRU and LFU built in. With Postgres, you're writing your own cleanup logic with delete and some heuristics. It's doable, but it's extra work.
Next up, job queues. Postgres can be used to implement job queues, though it's not a direct replacement for RabbitMQ, which is optimized for message queuing and delivery.
For updates, skip locked is the key here. It lets multiple workers pull the queue without blocking each other. If a row is locked, the next worker just skips it and grabs the next available job.
That's huge. Before skip locked, you'd get lock contention with workers waiting on each other. Now you get much lower contention, which is exactly what you need for a queue.
You claim a job by selecting its ID with skip locked, capturing that ID in your application, then updating its status to processing in the same transaction. If the worker crashes, you can reset jobs that have been processing too long.
To avoid polling, you use listen and notify. When you insert a job, you notify a channel. Workers listen on that channel and wake up instantly, sub-second latency, no polling delay.
The catch is the payload limit. Notify can send up to around 8 kilobytes. So you typically just send the job ID in the notification, and the worker fetches the full row with skip locked.
That's fine for most cases. You're not trying to send the entire job payload through notifies. You're just using it as a wake-up signal.
By the way, if you're running queues in Postgres, my DBA's free health check will catch slow queue queries and lock contention automatically and give you the exact indexes or query rewrites to fix them.
When should you stick with RabbitMQ? If you're pushing more than 10,000 jobs per second sustained, Postgres is going to become a bottleneck. RabbitMQ is optimized for high-throughput message passing.
Routing complexity is another factor. RabbitMQ has topic exchanges, wildcards, fan-out. You can route one message to many queues based on patterns. With Postgres, you're building that logic yourself in application code.
And delivery guarantees. RabbitMQ has publisher confirms, consumer acknowledgements, and dead letter exchanges built in. With Postgres, you're implementing retry logic and dead letter tables manually.
Also, if you need cross-data center queue replication, like federated queues in RabbitMQ, Postgres logical replication isn't designed for that use case. You'd be fighting the system.
Last one, document storage. Postgres has JSONB. It can handle many document storage use cases, but it's not a direct replacement for MongoDB.
JSONB is a first-class type in Postgres. You can index it with GIN index indexes, query nested paths with operators like @ and dense, and it's stored efficiently in a binary format.
The killer feature is mixing document and relational data in the same transaction. You can have a users table with a JSONB preferences column and join that with orders all in one ACID transaction.
Mongo can't do that. You'd need to manage consistency between Mongo and Postgres yourself, which is a nightmare.
Here's a query filtering on nested JSONB fields. The @ operator checks containment. Does this document contain these key value pairs? And you can cast nested values to SQL types for comparisons.
To make this fast, you create a GIN index on the JSONB column. This gives you efficient lookups on JSONB containment and path queries.
Performance is good. GIN indexes improve lookups on JSONB containment and path queries, though actual speed depends on various factors like hardware and query complexity.
When should you keep Mongo? If you're at massive scale, tens of terabytes, needing horizontal sharding across dozens of nodes, Mongo's sharding is more mature than Postgres's native partitioning capabilities for horizontal scaling.
Schema flexibility is another one. If your documents have wildly varying shapes and you really need schemaless storage, Mongo is more forgiving. Postgres JSONB works great, but you'll often end up adding some structure anyway.
Geographically distributed writes, like multi-region active-active, Mongo handles better. Postgres logical replication is async and doesn't support multi-master writes natively without third-party solutions.
And if your team is already deep in the Mongo ecosystem, aggregation pipelines, Mongo-specific drivers, ODMs, the migration cost might not be worth it, even if Postgres could technically do the job.
All right, let's tie this together into a decision framework.
Consolidate if you're optimizing for operational simplicity, you're under moderate scale, and transactional consistency across your data is valuable. You'll trade some peak performance for fewer moving parts.
Keep specialized systems if you're at high scale. You need the absolute best performance for that workload, or you're using features that Postgres just doesn't have, like Mongo's sharding or RabbitMQ's routing.
And remember, you don't have to make an all-or-nothing choice. You can consolidate your queue into Postgres, but keep Redis for hot path caching. Mix and match based on what each workload needs.
Here are the key questions. First, what's your sustained request rate? If you're under 10,000 requests per second, Postgres can likely handle the consolidated workload. Above that, you'll need to benchmark carefully.
Do you need ACID transactions across what are currently separate systems? If yes, that's a strong signal to consolidate. Distributed transactions are painful and error-prone.
How large is your team, and what's their expertise? A small team gets huge value from consolidating. A large team with specialized DBAs might be fine managing multiple systems.
Are you using advanced features of the specialized system, like Redis sorted sets, RabbitMQ topic exchanges, or Mongo's aggregation pipelines? If yes, make sure you have a plan for replacing that functionality.
And finally, what's your latency budget? If you need sub-millisecond P99 latency, Postgres might struggle to consistently achieve it, especially under high load or complex queries.
One last thing. If you decide to consolidate, you absolutely must monitor before and after. Baseline your current system's latency, throughput, and error rate before you migrate.
After migration, watch for lock contention, especially on queue tables with high concurrency. And keep an eye on table bloat, because high churn tables like caches and queues can bloat fast if auto vacuum isn't tuned.
The goal isn't to prove Postgres is better at everything. It's not. The goal is to make an informed trade-off between operational simplicity and specialized performance.
If you're thinking about consolidating workloads into Postgres, you need to know your database is healthy first. My DBA's free health check will analyze your Postgres instance across 16 domains: query performance, lock contention, bloat, indexes, config, and give you the exact SQL fixes.
It's free. You connect your own database, and you get a comprehensive report in minutes that keeps updating every week. Head to my DBE Ton Dev and run your first health check today.